So hello again. Hello. Can you guys hear
Hello.
me? Right, so great. So it seems that most of you are already here. So again, let me just ask one. So do you guys have a question so far? Question or clarification? All right, so I guess none. So I have a question. So what is the use of capacitor? So why do we have capacitor? What is the role of capacitor on the electronic components? Anyone?
Sir, sir,
So,
it stores and releases electricity in a circuit.
yeah, that's the meaning of it. But why do we use capacitor? I think it's not necessary. But
Sir, sir, I think it acts like ano na yun? Like emergency power, sir. Like it stores energy, electricity, sir, and discharges it when there is parang nagkaroon ng drop down, yan o, nakalagay, sir. Parang emergency backup electricity, sir. Like so, ganun, I think.
it can work like UPS, you mean?
Yeah, sir, pero para sa circuit.
Practical power system. Well, yeah, because if you have
Yeah,
UPS, but no, it's a no. Okay, let me just explain.
ay, okay, sir.
UPS is real battery. It's using a real battery. Like it can store energy and then it can be used if there is an interruption on the electricity. Like for 10 minutes, 20 minutes, you can still use your computer because you have your UPS. But in capacitor, again, uh, this one only stores a very small amount of electricity. Like it doesn't maybe it can lit up one LED, but it cannot make the entire system work. Okay, so that's the reason why I've mentioned that this one only stores energy like for 2 seconds, 3 seconds, and then after that, all of the energy already gone. So it already releases everything. Okay, so to make it simple on why we have capacitors on our devices, especially on televisions. Okay, so just imagine that this is a television. Okay, so TV. Okay, sorry for my bad drawing. And most likely we have this, indicator, light and indicator right here, LED. Okay, so if this is green, meaning the TV is on, and if this is red, meaning the TV is up, right? So imagine this one. So this one is connected to the outlet, of course, for this TV to work. Okay, so let's just say it's connected to the outlet. And then there is a sudden power interruption. So one thing that you will notice is, let's say, everything's black out. Okay, and then you will notice that this light will, not go black right away. Okay, or it will not turn off right away. Okay, like it will slowly turn off. Like it still has a light, for 2 seconds, 3 seconds, or even up to 5 seconds. So did you guys notice that one on your televisions?
Yes, sir.
Yes, sir.
Okay. So the reason for that one is because this one has a capacitor. Okay. So meaning, so if we are going to draw this one, I hope you guys can see this one. Dito na lang. Okay. So this is the 0 volt, and then this is the positive cycle, and then the negative part. So most likely it's it's AC. Okay. So parang ganyan siya. Okay. But in some televisions, let's say they are using DC. So to make it simple, let's just use DC for now. Okay. So let's say it's stable using 220 volts. Okay. And then if there is a sudden power interruption, so it will drop down to 0, right? And we don't want this to happen. Okay. So most of the components of the a certain device or they call this one appliances will burn out or will get static or will have a damage if it will sudden receive from 220 to 0. Okay, and then the same vice versa, like from 0 and then it will receive, let's say, not only 220 but sometimes 500 volts. Okay, and then it will become stable and then go back to the 220 and then run again normal. Okay, so those two are very, very dangerous. So the sudden drop down and then sudden going up or having electricity. So they've come up with this idea. What if we can slow this one down? Okay, or as to like to control the sudden discharge of the electricity. Because with that, if it's suddenly slowing down like 220, 200, 180, 150 until it reach 0, then the components will not get shocked. So parang hindi sila mabibigla. Okay, so with that, if we have capacitor, it will slow down slowly. Okay, so it's like now having a 90 degrees or 45 degrees rather. Okay, going down. And then the same with the going up. If there is a sudden fluctuation, okay, of the electricity, then it will only go up slowly from 0 to 10, 30, 50, 80 until it reach the stable electricity. Okay, so with that, our components inside of this television is now safe, okay, or safer. Okay, at least not 100% safe, but they are now safer from the sudden drop down and then the sudden fluctuation of the electricity. Okay, so yeah, so the reason why we have capacitors is to make our components safe. Okay, so yun lang naman. So I hope you guys were able to get at one on why we have capacitors. So again, this is the types of capacitor. We have the ceramic disc and then the electrolytic capacitor. So again, for you to be able to see if it's polarized or non-polarized, so just take a look on the leg. If it's equal, meaning it's non-polarized, so you can use it any uh, polarity that you want. Okay, but for the non-polarized, so you have to follow strictly the connection of it. Like this one is for negative and then this one is for the positive. Okay, because if you're going to connect this one the other way around, then this capacitor will not work, or this will not permit the current that will flow through it. Okay, so the next one is diodes. Okay, so take note on this one. What is diode all about? Because this is the focus of this discussion. So diodes are components which are polarized. Okay, so they only allow electrical current to pass through them in one direction. So as this is strictly polarized, so we have to follow it. Okay, so this is useful in that it can be placed in a circuit to prevent electricity from flowing in the wrong direction. So the main reason why we have a diode is if you want to permit only the positive side, okay, then it will only accept positive. Okay, and then it will neglect the negative part of that electricity. Okay, vice versa. If you want to allow only the negative, then you can also do that one. So another thing to keep in mind is that it requires energy to pass through a diode, and this results in a drop of voltage. So this is typically a loss of about 0.7 volts. Okay, so yes, you heard this one right. So this is the only components that it needs to eat a certain energy before it can function completely. Okay, so it for silicon, okay, it needs 0.7, but for germanium, it only eats, or it only yeah, I think the most fitting term is it eats, okay, electricity. So it hits 0.7 for silicon, and then the other one is germanium, wherein it eats a 0.4 volts. So let's say you want to receive a exactly 5 volts, and then you're using a silicon diode, then you have to have an let's say power source of 5.7 volts. Okay, So 0.7 will heat up by your diode, and then the 5 volts will flow completely on your circuit. Okay, so the same with germanium. If it's germanium, then you have to have a 5.4 voltage source. Okay, so the ring found on the end of the diode indicates the side of the diode which connects to the ground, and then this is the cathode, and then it then follows that the other side connects to power. So this is the anode. So cathode for the negative, and then anode for the positive. So those are the terminologies that's being used with the diode. Okay, so later on we'll discuss more where is the anode, where is the cathode. Okay, but this is the anode and then this is the cathode, but I will discuss more about that one later on. But for now, let's talk about transistors. So this is also another component that can control electrical uh, or the flow of electricity. Okay, so we have two types of transistor. Okay, we have the NPN and then the PNP. Okay, so NPN have this where is that one? NPN, this one right here. So we have this kind of setup wherein it only allows electricity to pass from the collector pin to the emitter pin. So where is NPN? This one right here. So this is the symbol of transistor, and then this is the collector, and then going to the emitter. Okay, so we have the flow of current from top to bottom. So collector to emitter. So same with the PNP. It's just that just interchange those two. Okay, so it's now coming from the emitter and then going to the collector. Okay, that's it for the PNP. Okay, and then the reason why we have transistor is because this one has the capability to amplify, okay, a certain amount of current. Okay, so it takes in a small electrical current as its base pin and amplifies it such that a much larger current can pass between its collector and emitter pins. Okay, so the amount of current that passes between those two pins is proportional to the voltage being applied at the base pin. Okay, so this one is used for amplifiers. So the next one is integrated circuits or ICs. So for this one is very straightforward. So this is a miniaturized component. So as you guys can see, this is one single component, but it consists a lot of components like transistors, resistors, and then diodes. So one good example of this one is the 555 timer. Okay, so the internal schematic of this one has over 40 components in it. So if you're going to take a look on this one, it's like it can only store up to 10 components. Okay, even though like it's very compact, but it says here that it can store, no, it has 40 components in it. Okay, so yeah, that's it for the 555 timer, even though I think this is not a 555 timer chip, but yeah, I guess the 555 timer is larger than this one because this is LM8610, so this is a different IC. But anyway, so in here, as you guys can see, it has legs on both sides, left and right. So they have a meaning. So this is the schematic of this one. So we have pin 1, 2, 3, 4, and then going to the right, but it's on the bottom side, 5, 6, 7, 8. Okay. So in here, for you to be able to know where is the top one, okay, where is the 1, where is the 4, 5, and then 8. So just look for the notch. Okay, it's a brown notch on one edge of IC, which means it indicates the top part of that IC. Okay, so wherever is the top one, so on the upper left of that one, that's your number one. So most likely one is for the voltage, 2 is the ground, 3 is for the VCC, and then more ground, and 5 volts, etc., etc. And then most likely on the right side, this is where the programmable or program, okay, chips, okay, wherein 7 is work for let's say a timer, 6 is for another function, and so on and so forth. Okay, so different ICs have their own different functionalities. So keep in mind that some smaller chips have a small dot next to pin 1 instead of a notch at the top. Okay, so just find that the smaller chip. Okay, so it could be on the upper left or on the middle of that one. Okay, so we also have here potentiometers. So to make it short, this is a resistor where we can control the resistor, the value of resistor itself. So as you guys can see, it has a knob. Okay, so maybe from left, that is the smallest value, like 10 ohms only, or 10 mega ohms, okay, or 10 kilo ohms, okay, depending on the potentiometer. So sometimes we have 10 key potentiometer, we have 1 key, okay, and many more, okay, and then you can control it, like 10 on the most left, and then 50 on the most right. So call it one potentiometer. And then we have LEDs. So I will not discuss this one anymore, but just take a look on this one, and then you will already understand the part of it. So again, most likely, the smaller one is for the negative, and then the longer one is for the positive. Okay, and then if ever that you don't want to check the leg, so just find the flat spot. So wherever it's a flat spot, that is negative one or the cathode, and then the positive one is for the anode. All right, and then switches. So we have three types of switches in here. Switch, which is just the normally open or normally closed. Okay, wherein from where itself normally open, by default it's an open circuit, so it's off. And then once you activated it, then it will close the circuit. So there is a flow of current. And then we have the other way around. We have the normally closed, wherein by default it's closed, and then once you activate it, then it will open, or it will stop the flow of current. And then we have the second type of switch, wherein it can open both and then close both connection. My bad. This is just the single. Okay, so this is the both double open and then double close. But this one open and then one close at the same time. So if you're going to turn on this one, it will off one of the connection, and then vice versa. If you're going to off this one and then turn, just turn off that one, and then it will turn on the other side of it. So we call this one SPDT, or single pole double throw switch. Okay, it can both open one connection and close another when activated. And then you can also have two at the same time. So two of it are open, and then at the same time two of it will close, okay, or will open the circuit. Okay, so we call this one DPDT, or the double pole double throw switch. So DPDT. Okay, so this would break two separate circuits and then open two other circuits. So most likely we only use this one, the normally open or normally closed. So I haven't used this kind of technology. Okay, maybe for some devices, or some in a certain situation, you'll be needing this one. Okay, where it will forcefully close the other one and then open the other one. So if you need two, then you can use DPDT. Right. And then batteries. So this is very, very simple. Battery stores an energy wherein it can release it if you're going to use it. Okay. And then we have this kind of connection. We have the series and then the parallel. So in series, if you're going to combine them in series connection, so of course you will come up with, let's see, if we have three 1.5 volts AA battery, then you'll come up with 4.5 volts. Okay. So the current will still remain. You're just increasing the voltage capacity of your battery. Okay, so meaning it will take longer, okay, than the usual one AA battery only. Okay, so if 1.5 volts can last for 3 hours, then just multiply it by 3, then you're now having a 9 hours of battery. Okay, however, if if you're needing more current than the energy itself, or than the storage of voltage itself, then you have to place them in a parallel connection. Like for example, 1.5 volts has a current of 1 amp, and then you need let's say 3 amps, then you have to connect them in a parallel connection. So with that, the voltage itself still remains as 1.5, but you now have a higher flow of current. Okay, so that's basically the how we use batteries, right? Okay, so any questions so far up to this point? questions or clarification? Okay, so let me ask, okay, Miss na lang, Miss Kapad.
Sir, none, sir.
Great. So she's around. So most likely, when I call a random person, that person doesn't respond because that someone is doing something else. Anyway, okay. So if you guys don't have a question, then let's move on. So breadboards. So I hope you guys have already, touch or see one in real life. Okay. So I highly recommend you guys to buy one, okay, because you guys are computer engineers and you'll be needing this kind of thing. Okay, so this is very, very helpful, especially if you are already second year, third year, and then you're now near in getting your thesis, okay, or making your thesis. Especially that nowadays, Sir Dion requires a software and hardware. It's not just a pure software anymore, but it requires hardware. Then you have to integrate AI and then machine learning. So as really as of now, I would like you guys to buy one and then start learning about breadboards. Okay, they are fun to use. They are quite interesting, especially if you are more into, let's say, robotics, robotic arm, RCs. What else? Mm, Like working on sensors. So this is a very, very good uh device, not device, thing or tool. Okay, that you can have if you're going to experiment on this kind of thing. Okay, so breadboards are especially boards for prototyping electronics. Okay, so yeah, just buy one and then you can start with LEDs and then you can buy wires. So they are quite cheap actually, just by having maybe 200 pesos, then you can already buy some resistors and then LEDs and then capacitors maybe if you're going to need it. Okay, and then wires. Okay, and then just use double A battery or triple A battery to make your entire circuit break. Okay. Well, anyway, so let me discuss the connectivity of this breadboard right here. Okay, so on both sides we have these pass rows. So meaning it has a connection from top to bottom. Okay, so it has a column connection. So this one is connected up to here. Okay, though for you to be able to make it really connect from top to bottom, so we have to have a jump wire right here. Okay, and then right here, and then right here. So we could say now that this is connected to this one. Okay, and then as you guys can see, most likely we only have two because this one is most likely for the positive, or let's say negative, and then the other way or the other one is the positive one. Okay, so again, this is where we connect, let's see, a bar and then put it right here. Wherein, let's say this is an LED, and then let's say it's connected right here, and then the negative one or the positive one will go right here. So with that, you now have a closed loop on that LED. Okay. So yeah, and then the middle one. So the connectivity of this one is via row. So I don't know why is it called columns, connected up rows, and then bus rows. Okay, so they call this one bus. Okay, bus only. Let's just say bus because it's quite confusing when you see rows. And then this one is still, yeah, in the column way, but it's in connection of a row connected rows. Okay, so yeah, this one is connected to this one is connected to this one, and then if you want to connect this one to here, then you have to use a jumper, okay, or a wire. Just connect this one to here, then meaning this one now is connected to here. All right, so you will appreciate this one once you have a real breadboard in front of you. Okay, Anyway, so yeah, that's the connectivity of the breadboard. And then for the wire, so the only thing that you guys need to worry when it comes to wire is the gauge. Okay, when buying a wire, especially if it's for prototyping, so you have to use 22 gauge. Okay, so this is the most recommendable size when it comes to breadboards. So you can use a higher gauge or lower gauge, but just to take note that it might cause a problem or an issue. So let's say higher gauge uh, will eat up more voltage, because as we may all know, this one also has a resistance. Like the longer the wire, okay, the more that it has a voltage drop in it. Okay, so vice versa, if you have a thinner wire, then yes, it has a less resistance, but there is a big chance that it will burn. Okay, due to very being very thin. Okay, especially that if you're flowing a high or high flow of current, and then for a very long time. Okay. So most likely you guys learned those one. So the black one is used for the negative or ground, and then red is used for the positive. Okay, so yeah, you can interchange them, like black for positive and then red for ground. But that's not a good practice, because in the world of electronics, when you see red, it's always positive, and then when you see black, it's always negative. So if someone will handle your project, okay, or your they call this one, the one that you made, okay, for the prototyping. So make sure that you will not get confused. Okay, so black for negative, and then red for positive. Okay. Well, anyway, that's it for the basic components. So let's now move on to semiconductors. All right. So for semiconductors, these are the 50-50, the one that is half conducting and then half not conducting. Okay. So the definition of this one is it conducts current, but only partly. Okay. So most semiconductors are crystals, like something like this. So they are made of certain materials, most commonly silicon. So the one that is most likely being used on the industry, okay, is silicon, because we could say that this is the perfect semiconductor, and then the others, so they're just like alternatives, okay, or they have their own special usage, okay, but most likely when it comes to general semiconductor, silicon is the best. Okay, silicon is used extensively as a semiconductor in solid state devices, the one that we have in our computers, SSDs. Okay, so this is the upgraded version of the HDD, so SSD. Okay, so we also have other usage of silicons, like for dynamo or transformer plates. So just to take note that silicon and then silicone are two different things, okay, or two different elements. So silicone is used in silicone oil, cosmetics, hair conditioners, sealant, and then many more. Okay, so yeah, it has an E and then S on that one. But for the silicon, this is the semiconductor material that we use on the electronics. Okay. So here are the other examples of semiconductors. Aside from silicon, we also have germanium, just like what I mentioned a while ago. And then we also have gallium arsenide. So in elements near the so-called metalloid staircase, is one right here. So the green one, I don't know if this is green, so light green. So we have boron, silicon, germanium, arsenic, stibbium, and I don't know the other three. But yeah, those or all of those are semiconductors. It's just that yeah, they fall under the semiconductor. Okay, close enough. Okay, but silicon is the most perfect semiconductor, because again, going back to what we have in here, is that one. So just to take note again that 1 to 3 electrons is considered as conductor already, and then semiconductors is 4, and then 5 to 6 electrons are insulators. Okay, so later on you will know why silicon is the perfect semiconductors, and then the rest is not that effective anymore. Anyway, so after silicon and then gallium arsenide is the second most common semiconductor and is used in laser diodes, solar cells, microwave frequency integrated circuits, and others. Okay, so we could say that 70% of the semiconductors are silicons, and then 20% are gallium arsenide. Okay, or you could even say 15%, and then the remaining 15% are germanium. So they have their own special usage. Okay, like gallium arsenide is the second most common semiconductor that's being used with those kind of technology. Okay, well, anyway, so let's talk about more elements. How are they being made? So let me make it short. So we have this element, the oxygen, and then hydrogen. So we have these electrons right here. So once they combine, okay, so that's the time that they will, come up with another element. Okay, like by combining H and then let's say two hydrogen into one oxygen, you will come up with H2O. Okay, so yeah, we have this outer valence electron, okay, or valence shell. Okay, so just do take note that for you or for us to able to have a semiconductor, it must only have 4 electrons. Okay, so this oxygen has 1, 2, 3, 4, 5, 6. So it has 6 electrons. Okay, but when see semiconductors, it must only have 4. So here's one example, okay, of binding of a semiconductor. So as you guys can see, we have 1, 2, 3, 4 outer electrons only. Okay, so as you can see, all of them are silicons. So just by forming this kind of bond, so it's like we are forming a perfect combination of a silicon. So this is a perfect semiconductor at the same time because it only has 4 electrons. Okay, going back right here. So semiconductors has exactly 4 electrons only. But this one, so it has 6 electrons, and then once you combine more elements inside or outside of it, then it's like falling on insulators already. Okay, but for silicon, it's a perfect 4 electrons. And then for the other two, so we'll discuss this one later. For the other two, okay, so we have this graph. Okay, so this is also a semiconductor. However, as you guys can see, it's being surrounded by silicons, okay, wherein it has a perfect 4 electrons, okay, but this antimony or stibbium, okay, has 5 electrons. So as you guys can see, we have 5th valence electron of antimony, wherein if we have 5 valence of electron, it's more likely falling on the insulators already. Okay, so it exceed 1 electron. Okay, and then if you have this kind of combination or element, so it's not pure perfect silicon anymore. It's now like falling on the insulator part. Okay, so that is why antimony is not used as a semiconductor. So the same with the other one. So we now only have 3 minutes left. So I think we're going to have part 3. All right, so as you guys can see right here, it's being surrounded by perfect semiconductor silicons. However, it's now impure, okay, because we have a boron right here, wherein, as you guys can see, it only has 3 electrons. And then again, if it only has 3 electrons, it's now falling on the conductors, okay. So that is why, what is that one? That is why boron is not also used as a semiconductor. Okay, so for us to be able to come up with the perfect semiconductor, which has only 4 electrons, so it must be the it must be the silicon only. Okay, so yeah, that's the explanation when it comes to two types of extrinsic semiconductor. So for the this one, we have 2 types of semiconductor. We have the N-type and P-type. So to make it short, N-type has more electrons, and then P-type has more holes, okay, or the positive energy, or let's just say proton, okay, because that's the positive one. Okay, and then we have the N-type material, wherein we have the antimony, arsenic, and then phosphorus. Okay, so this is more on electrons, and then we have the more on holes, okay, or more on conductor type. We have the P-type material, which is the boron, gallium, and then indium. Okay, so only have 1 minute left. So do you guys have a question so far? Question?
None, sir.
None, sir.
Okay, so since we still have like 17 slides more, so we cannot finish this one in in 1 minute. So we'll be having a part 3. So I thought we're only going to have a part and part, but anyway. So yeah, let's have a short meeting on part 3. So maybe 10 to 15 minutes only. So goodbye for now, and then see you guys later on part 3.